logarithms. All right, so if we're talking about powers, right, let's talk about powers of 2, all right? So let's just start very slow. 2 to the power of 1 will give us how much? 2. And then increase the exponent, 2 squared will give us 4. And then increase the exponent again, 2 cubed will give us 8. So take a look at what happened. Nothing too fancy, but let's look at what happened. When I increased the exponent from 2 to 3, my values jumped from 4 to 8, right? That was a big jump. So I skipped all the numbers in between, 5, 6, 7, and so on. Now, what if, though, I wanted to raise 2 to an exponent and get a value of 6? I skipped it completely. So how much would you say 6 would be? What exponent would you say would give us 6? A decimal, how much? So, so it would be a decimal, what though? So 2 to the power of something between 2 and 3, right? So if I were to do, so if I were to do 2.5, right? 2 to the power of 2.5? No, 5.7. So what do you think? It would be higher than 2.5, right? So, well, 2 to the power of 2.6, too high. So what do you think? 2.7 is too high. So 2 to the power of 2.55, somewhere between 2.5 and 2.6. Almost. Huh? The point is that you can do it. It just takes an unnecessarily long amount of time. Like, you could sit there and do it, right? But it takes a little too long. I sure do. But so will you in a minute, right? In a few minutes. So to answer that question, to answer this question of 2 to the power of what gives you 6, right? What we need is a logarithm. So here we go. That's what logarithms are all about. Okay? Now, a logarithm will answer the question, right, of what exponent of a given base will result in a specific value. So then, if I'm doing this business of logarithms, what is it that I'm finding? I'm finding what? I'm looking for what? A base or an exponent? I'm looking for an exponent. So the trick to doing logarithms is this. The sooner you connect the words logarithm and exponent in your mind, the better you will do with logarithms. So what is a logarithm at the end of the day? It's just a what? An exponent. A logarithm is an exponent. So this is one of the things where if you're walking down the street and somebody taps you on the shoulder and says, "Excuse me, what's a logarithm?" Exponent. Okay? Right there. Okay? Right. So, in fact, let's explore logarithms. Take a look at this. 3 to the power of 2 is equal to 9, right? You've seen it all the time. It's nothing too mysterious. And I've got some color-coded action happening here. So take a look here. The 3 is the base, right? We call that a base. The 2, we call it an exponent. So that's, 3 squared. And the 9 is the value. Now, we can write the same exact thing in terms of a logarithm, right? So the template for a logarithm is this. Log base b of the value equals the exponent. Yeah, you've done this previously. So log base b. That means the base here, the 3, right? The 3 that was a base goes down here. Log base 3 of the value 9 must equal the exponent. All right? So this is another way where if you have a logarithm always equals to an exponent. All right? And logarithm always equals to an exponent. Logarithm always
what is the 9
equals an exponent. 9 is the value of the power.
I just don't say that.
Well, they are the same because look, In this hodgepodge of numbers here, what's the base? 3. And what's the exponent? Because every base needs an exponent. What's the exponent? No, the exponent is the answer, 2. Right? So 3 is the base. 3 is the base. 2 is the exponent. What value is it? 9. The reason why they put it that way is because this is the question. If I see this on a billboard, log base 3 of 9, what I'm looking for is, what is the exponent of 3 that gives you a 9? Okay? So, if I see this on a billboard, log base 2 of 8, okay, what that means to me is, what is the exponent of 2 that will give you an 8? 3. Right? So here, log base 5 of 25. What is the exponent of 5 that would give us a 25? 2. You see how it works? Okay. So let's go back and forth then. Take a look at number 2 here. You have 2 to the power of 5. Now what would that equal to? 32. Good. So now here on the right, log base. So what's the base here? It's a 2 of 32. Now that needs to equal the exponent, which is how much? 5.
So we're just writing it out.
We're just writing it in different notation. All right, take a look at another one. 4 squared is what? 16. And now how would I write it in terms of a log? Log base 4 of 16 equals 2. All right? So again, if I were to just see that on a billboard, it's, oh yeah, base is 4, exponent is 2, gives you 16. Okay? All right. Now, take a look at this one. I've given you the logarithmic form. Can you write that in terms of the exponential form? Yeah. Exponent 3, right. So, base 3, exponent is also 3, and that equals 27. Okay? So that's how we can go back and forth between logarithmic and exponential form, right? And here we go. That's just what I said. And this is the book's version of exactly what I said. I took it and I expanded it here for us to really see what it is that we're doing. So same exact situation. Exponent, right? This is the exponent. You can see here it's the exponent. And then b is the base, and you can see it's the base. All right, so since we're dealing with exponents and powers and all that good stuff, you know that when it comes to zeros and ones, special things happen, right? Because if the exponent is a 0 or if the exponent is a 1, it's different. So let's take a look at the properties of 1 and 0 as an exponent. Okay, so let's look at this one. Any number raised to the power of 1 will give you what? Any raised to the power of 1? Same number, right? So for example, 5 to the power of 1, 8 to the power of 1. So any number raised to the power of 1 is itself. Okay? Any number raised to the power of 0 is what? 1. All right, so let's take a look at this very quickly. 2 to the 0 then gives me what? 1. And if I were to write this in logarithmic form, look, log base is 2, exponent is 0, 1 goes there. So take a look at the other one. 3 to the power of 0 then would be 1. 4 to the power of 0 would be 1. B to the power of 0 would be 1. All right, so go ahead and fill in the right side of this. Did we all get the same thing as this? Yes? Okay, so what does that tell you then? Do you see a pattern? What's the pattern? Look at these just here. Do you see a pattern? Well, from here as well. Anybody? Right. So what's happening? Is the base staying the same? No, the bases are all different. What's the same though? Right, this is the same, right? 1, 1, 1. So what do you notice then? No matter what the base is, if you have log of 1, what is your answer going to be? 0. Because no matter what the base is, what you're looking for is b to the power of what gives you 1? 0. 4 to the power of what gives you 1? 0. Right? So no matter what the base is, log of 1 is always going to give you 0. Okay? Now let's do that with this next one. Right? So go ahead and fill those in, right and left side. And I'll give you like a half a minute to do that. What patterns do we see here? Right? What pattern do you see here? The answer is the same. What's changing? The bases are changing. Right? But the base and the value are the same. You get a 1, right? Log 2, 2, you get a 1. Because you're always asking, this base to the power of what will give you the same thing? Well, it's a 1, all right? So always remember, log BB will give you a 1. So now take a look at what happens. You guys just now, on your own, came up with 2 of the properties of logs, right? You have to, so it's not a matter of memorizing. We just went through this, so we now understand, right? That if I have log b of 1, what is that going to be? Well, you have a base. What should the exponent of this base equal to in order for you to get a 1? 0. So that's always going to be a 0. You see that? So the next property is log base b of b. What should you have? Right, the exponent of b should be a 1 in order for you to get a b. Okay? Take a look at this one now. Let's take a look at this one. Log b to the x equals what? Okay, so this number is the exponent, right? So now take a look at what the question is. What should you have as an exponent of the b in order for you to get b to the x? What should the exponent of b equal to so you have b to the x? You have b. What is the exponent to give you b to the x? Is it x? Yes. Right? So it's x. Okay? So take a look at this. Log base 3, 3 to the x. What should I have as an exponent of 3 so I get 3 to the x? X. That's all. So you could just cross out log 3, 3 and just get an x. Okay? All right. One more preliminary thing we have to do is this. We need to talk about roots as exponents and fractions as exponents. All right. So back in Algebra 1, whether it was 1a, 1b, or 1, you learned that the square root of 1 over 2 can be written as 2 to the 1/2. Do we remember this? Okay, you learned this in Algebra 1, right? So if you have root 2, that could be written as 2 to the 1/2. If you have root 5, that could be written as 5 to the power of what? 1/2. Okay? Now, if you have a different root, if you have a cube root, you see that number there is a 3? Now you have 2 to the power of 1 over 3. All right? So whatever that number of the inside the root is, this number, this is called an index, that becomes a denominator of my exponent. Okay? So then what would the 25 be? 25 to the power of what? 1 over 3. But now, can we make the 20? Can we go further with the 25? Can we write the 25 as a power of a more elemental base, of a smaller base? 5, right? So can this be written as 5 squared to the power of 1 over 3, right? So it's just simplifying it, and now it'll be 5 to the power of what? Well, it's 2 times 1 over 3, 2/3. Okay? So let's do one more like that. If I have, for example, the 5th root of 49, right? First of all, that's 49 to the power of what? 1/5. Right, and that's 7 squared to the power of 1/5. And that's how much? 7 to the power of 2 over 5. All right, this is going to be important later on when we're doing like our logarithms. All right, so that's one of our preliminary work. Next is negative exponents. All right, here, what is the exponent of the 2 on the bottom? Well, right, so we can rewrite this as 2 to the power of -1. Okay, now, what if I had a 1 over 4? How can I write that? Right, it's 4 to the power of -1, but can I write it in terms of 2's? Right, 2 to the power of -2. Okay, so what about 1 over 25? What about 1 over 25? How can I write that? It's 5 to the power of -2. What about 1 over 8? How can I write that? Two to the power of -3, right? So I just, so in my mind, I just say, okay, 8 is 2 cubed, and then it'll be 2 to the power of -3. Okay? We're good with this? All right. So what I'm going to do is stop here, and you won't have any homework tonight. I'm going to do more of this tomorrow, and I will give you a handout for homework for tomorrow. Okay?